Good evening, everyone, and welcome to Sydney Alt.net April. So please comment in the chat if you're there, so we know we have an audience before the numbers start coming through. So quite a lot of people RSVP'd, so there'll be quite a few people in the chat. Now we have Phil in the speaker room, who is a very welcome and quite frequent presenter at our group too. I think actually the last two times has been on AI, right, as well, Phil?
Oh yeah,
Yeah.
it's like
At
me. I
least,
check
at
it
least
every
two,
6
not
months.
more, I think.
Yeah,
Yeah,
and every time Phil's had something like quite new and exciting to show us. So yeah, Phil's been telling me a bit about it already. So I think today is no exception at all. It sounds like it should be really good. If you've been messing around with AI memory, markdown files, etc., then this should be next level stuff.
yeah.
So let's see how we go. Still waiting. It takes a little while for the numbers to come through, but we've
Let's
got
give it a little bit.
plenty of people commenting in the chat. We have the 2 JetBrains licenses to give away as usual, and so stay to the end, and I'll ask you 2 questions, and Phil can check your answers as well to make sure I've got them right before giving the prizes. And we have Francis here as well, as usual, with his very grand house in the background.
Yeah, I wish I had a grand piano. Actually, I do have a grand piano. I won't tell you that story because it's a bit of a messy family affair. But yeah, if you ever catch me in the pub, ask me about the grand piano in the house, and I'll tell you a riveting story.
In person over drinks sort of story.
Definitely, absolutely, yeah.
All right. Well, I still haven't got any proper numbers through StreamYard, but we've got lots of people commenting, so I think we've got people here, so we might as well start, I think. Anything else we want to add, Francis, before we hand over to Phil? Anything upcoming?
Oh, yeah, we have. I think we have Damien coming back next month.
Oh, that's right. Yes,
Yeah,
we do
to talk about
indeed.
messaging. In June, we have our drinks. So if you're in Australia, please come along. Yeah, we've
So Damien
had
in May, drinks in June.
yeah, and then July, I think we're supposed to have Matt Goldman. So I think, yeah, James, myself, and a few others. We went to his, he does a podcast, and we went to his first ever in-person podcast, and yeah, he kind of showcased like a live AI kind of chatbot kind of thing that was very kind of amusing, and he's going to talk about how he kind of built it and all the kind of like hitches he kind of ran into. So I'm hoping that's going to be an in-person one, but we'll see. Anyways, I actually haven't gotten around to asking if we can get a venue for that, but yeah.
Yes,
And then I think, yeah, there's a few speakers that I'm kind of speaking to, but nothing really concrete yet, so to speak. So
sounds good. All right. Well, let's. You ready to go, Phil?
Yep.
All right. I'll bring Phil's screen in. Here we are. Is that big enough? If you can't read the text, then say in the comments, and we can maybe make it a bit bigger. So I'll keep an eye on that. But yes, very excited to hear Phil's talk and learn some new tricks that I can probably use, and you can probably use in your day-to-day coding as well. All right,
Okay.
over to you.
Right. So this is going to be an interesting talk because if you don't know me, I check in. It's like I do a 6 month stand up with alt.net every time or so, and every time I check in, I'm always building something different. In this particular case, I actually had an itch to scratch, and this is really just kind of a mix of a brain dump of some of the stuff that I've built on it. But at the same time, this is the first time I've actually shared this with anybody, at least within the technical capacity. So let's start with, there's a couple directions we could talk about in this talk though, but I think one of the things I mentioned on LinkedIn, if you looked, is that I actually forked open code and bolted on my memory system onto it so that this particular private fork of open code does not do any kind of compaction. So that means it just goes on forever. You will never, we'll jump into this one, and the reason why I don't have any slides is the entire demo is actually the memory system and me talking to an agent and asking it to pull up what it remembers as a part of this. Some interesting topics that it has. It's kind of hard to try to condense this in an hour because there's a lot of stuff that has been done. But at a high level, how it started was like everybody else. Like after that, my last alt.net talk, I started working with Claude Code. And I realized that despite how good it is, the limitation is that you could still, number one, it forgets all the time. Number two, even if you had what I call the basic memory system, which is your hard disk and a bunch of markdown files on disk, you could never really use all of it, simply because what would happen is, and this happened to me many times, is that even if you have about 5 or 100 files on disk, if you want an agent to actually understand it all, it has to read all the files, and by the time it gets to the 10th or 20th file of all the research that you've done, it completely just stops, runs out of memory, and then you got to restart the new session. Of course, with Claude Code, what they've done is this form of kind of reactive compaction, so that if, for example, with Claude models, you've got around 200K tokens. When you get to, say, the 180K token mark, the whole thing compacts and it kicks it back down to, say, 150. Same thing that happens with open code. Like, for example, when I work at work, I have a stock version of open code. And one of the things I notice right away when I just look at what I have here at home versus the one at work is that when I do like 3 or 4 prompts, it actually, you could see the screen pop up that does an entire compaction summary of the session, kicks the tokens back down to, say, 50K from, say, 200, and then all of a sudden it forgets every single detail that you were talking about. Even though you as a human could scroll up and you could see, I just talked about that. So it was quite disjointed. But the interesting part is that what you're going to see here is kind of an evolution. Like, to be honest, nobody sets out to build a memory system. And secondly, I'm not out to sell this, so let's put that out of the way. I'm just out to show this. So no multipass here. Let's put it that way. This is really just talking about how this was built. Everything that you'll see and won't see here is all written in .NET except for open code. So you could think of open code in this case as the front end. The back end services are just Docker containers, REST APIs, and using principles like actor systems and CQRS and event sourcing. Everything that you are absolutely familiar with from back in 2016. This is all that. Now, that being said, the challenge for me is how do I condense it? Because there's a couple ways we could actually take this. So when you're dealing with a memory system, or if you let's work backwards from what I call infinite context, which is this idea that you could have a session that just keeps going on forever. And there's some really interesting tricks that I got out of that because for a while I had to work with GitHub Copilot as my context limits, and 128K. That's like living in a bedroom house in Hong Kong. It's like you can barely move. But there's a lot of interesting things with that. The other way is the actual memory system itself that plugs into everything. Now, I've been waffling on though, but it's easier for me to show you what the memory system can do. Now, if you're familiar with, obviously you're familiar with MCP servers, let's start with the basic stuff. How do you get 2 agents to be able to talk to each other? That's an easy one. And the easiest way to do it is you have a REST API. You've got an MCP server that talks to that REST API. and you get two different agents to talk to the same MCP server that talks to the same REST API. That is the gist of the most basic thing. There's a lot more to this, but it's easier if I show you. So let me show you what I've got in the screen right now. So right now, if I just close the settings, I've got two windows. Now, one of the windows that you see here is actually my Windows machine here running. They're both running the same private build of OpenCode. This one is actually in my laptop, Linux laptop in my house, connected somewhere else. But they're both connected to the same memory system. So if I, let me just, okay, so what I'm actually doing here is that every single one of these agents already knows how to talk to my memory system. It's already in the prompts. My memory system is called the bag of holding, and I'll explain to you why it's called that. But while it's pulling this up, I call it the bag of holding because it's from, I think it's D&D lore or some magic movie where it's a pocket dimension where you could keep throwing things into it, and somehow magically it could store everything there. Now, the bag of holding, as I affectionately call it, it's going to sound like magic because what it allows me to do is have 4 or 5 agents writing to the same topic. And on one side, it's all immutable. So that means that I could have 10 different agents writing to the same topic at the same time. But on the other side, it automatically compresses on the fly. And it guarantees at any given time, I can, depending on how big the content is, I can always be guaranteed to pull in a token size, a token budget of 4, 8, or 16K tokens. Now, what this means is that I can do things that I was never able to do previously with my past iterations with markdown files. That means I'm able to do things like do deep research with Claude desktop, have it connected to the MCP server, push everything it knows about one topic into one, what I like to call hashtag, but they're basically topics. And they're writable. And I can actually mention it to any one of these agents, and they'll be able to read the summary that is automatically computed almost in real time, but there is a bit of a lag. So, for example, in this case, I'm working with the AltNet Talk AI memory, which is something I already did beforehand. And it's giving me a summary of what's actually there. But the nice thing about this one is it does have different resolutions of what data it could pull per topic. It could be 4K tokens, so that means that I don't run into any issues like I did before with Obsidian, where I could have 1,000 topics or 1,000 different markdown files, and I wanted to pull up, say, 20 of them. This would pull in no more than, say, if I pulled in 20 markdown files, what this would do is it would probably get up to around 80K tokens. But the context management system itself guarantees that it never overflows. And I'll get to that later. The context management here does not do any kind of reactive compaction. It just keeps going. If I pull up a previous session, what you're going to see when I scroll up is that there's no actual compaction markers. If we keep going with this session, it'll just keep going and going and going, and usually it lasts about 7 days until I get bored and I start something new. But here's the interesting part about this, and I was going to save this for later, but it's, if I pull up the side panel, okay, task panel, okay, side. Okay, so this is obviously not your usual OpenCode build, but does everybody see this? It says BOH, and it's got that hashtag there. So this is tied in so closely to the memory system that even the agent's context memory can be referenced from another agent. So what this allows me to do is I can have an agent that does research onto a code base. I can actually say, well, I can do this. By the way, this is one machine. If I switch over to this one,
might need it a bit bigger there, Phil. Sorry.
yeah, it's okay. I'll try to explain what I'm doing here. So all I'm doing here is this is the one machine that has the session we're in now. And this is the other Linux machine that I've got. So if I do this one will be able to access all the context for that particular session. And it'll actually tell you what's going on in that session. And it'll guarantee that no matter how big that session is, it's usually around 4, 6, 18K, 4, 8, and 16 K tokens. Now, this might not sound like a lot, but the interesting thing about this is that when you have this layered on top of each other, where every single agent, including the sub-agents, is able to has their own hashtag, the interesting part here is that the orchestration doesn't necessarily become Opus. It doesn't become your state-of-the-art LLM. It's actually the memory itself that becomes the orchestrator. I'll give you an example. So I can launch about an investigation of around 10 different parallel agents. And usually what happens if you run them in parallel is they all save it to disk. If something happens, you have to actually go through every single one and either look at the file that it writes or copy and paste what the research is into the prompt. But in this case, it could be any particular hashtag that I have. Everything works around a hashtag, and I'll explain to you why it works that way. But essentially, everything, there's about 11,000, so it's 11,569 topics. There might be more or less, depending on the day and how many stuff is retired and temporary, but I'm not going to get into that too much. But the idea here is that hashtags for every single LLM that you have today is so well known that telling them you have to write to a hashtag and read from one is so native that I've seen cases where no matter how dumb the LLM is, it's able to pull from the hashtag, pull from the memory, and explain how that is actually put together. So in this particular case, let's drill into this. So before I continue, does anybody have any questions so far? So I know this looks really simple, and it's built that way because this is essentially built for me as a dev. I wanted something to be seamless, but I wanted it to be pervasive enough that I could use it everywhere that is connected to an MCP server. There's even a CLI version of this so that if I could plug it into any agent if I want to, so that it runs the CLI and it could actually query the same REST API that actually has these topics. But the key thing to remember here that makes it really useful is you can do research in parallel and like 20 or 30 different topics, and it's all immutable. So the interesting part about this is that everything that I've built here is based on stuff you already know. Like, do you know CQRS? Everybody does. Does everybody know about immutability and REST APIs and microservices? This is all on my infra, but again, this is all Docker containers. This is all .NET. I'm using actor systems in the background and event-driven systems so that every time I write to a topic, there's a chain of events where it just fires an event and then recomputes what the summary is. But the reason why you don't get any pauses from compaction is that it's done offline in another machine. So one of the things that I just realized in hindsight is that coding agents that we have now are essentially doing a synchronous block or a lock on or write. and it freezes the world until that summary is done, and then lets go of it, and then lets you continue. But what this does is it flips it around and says, well, you could keep going. The actual summary in memory is an actual either block of 8 16K tokens that is fixed and mapped in the context memory. So what happens is that I might have messages that keep coming in, but that section never grows beyond 16K tokens. On top of that, it's gonna feel really weird because I can have this sit at around 120K, 200K tokens, and it never overflows. Why? Because every section is mapped, and every section dynamically sheds as the session keeps going. So I might have one for the historical section, which actually maps to all the conversation history that you've had so far. I might have another one for all the conversational turns. But what this is actually doing is that it's almost like it's 3 or 4 dimensional, where regular compaction, what tends to happen there is you wait until it gets to around 100K, 150, 175K tokens, and you compact and it gets back to 0. But this one's much different because it maps every single section in the memory and locks it to a certain size. Of course, they're going to fluctuate, but the key difference here is that the underlying memory system is immutable. So all the data that we have is actually stored there. What is mutable and what changes is the continuous summaries that are computed in the background. And it, to be fair, it is a lot of LLM calls. So there's no such thing as a free lunch. I've found ways around this, but the trade-off here is I get a seamless experience that allows me to write specs in, say, Claude Desktop and talk about what I want, and then cut over to, in this case, it's open code, but it used to be Claude code, and say, read this specification and build it, or give me an implementation plan. I have also been able to do things like do investigations into different coding, other frameworks, for example. I've done a couple for Gastown. I've done one for OpenClaw, although I decided against OpenClaw because there's too many security issues and I can never lock it down within my infra. But the idea here is that I'm able to do this kind of research and store it in memory and recall it in a way that is boring, but it's really useful. Like what I'm talking about right now, there's not a lot of flash to it, but the fact that I don't actually have to have the same conversations, and I can pull. I'll give you another example. So I'll if I ask it to tell me about how the bag of holding architecture works, I can say, tell me about the BOH.
Got a few questions for you as well, Phil, when you get to a good point.
Sure. Okay. So again, this is exactly the problem I was trying to solve at the time. Everybody's had this problem. Number one, you get into a good conversation with say Claude, and then you jump to another conversation, and then you're like, well, I don't want to have to explain this again. Now, what this memory system does is, because you're saving everything to a hashtag, you tell it, like in this case, tell me about the bag of holding architecture and how it works. It'll look it up, but it'll do it in such a way that's not quick, but it saved me an entire conversation in several paragraphs of how it works. The other thing, while this is running, that is also worth mentioning is that these topics are not in isolation. It's actually, they have related topics. So the LLM knows how to crawl the topic graph, and they're clustered together. So that effectively, I've seen on many occasions where I told it to read one thing and it followed the entire topic graph, and all of a sudden it started to talk like it always knew it. So as you can see here, I'll explain what it basically is. But as I said before, it's an event store for knowledge. Writes are expensive because you have to kick off a compression, but at the same time, it is eventually consistent. The thing that is useful here is the level 0 blocks. You could think of this as hierarchical compression, and it's in a pyramid, so that the lowest level blocks are essentially immutable blocks, and the pyramid that's built on top of it are higher level summaries of lower level blocks. So it's interesting because the reads are actually cheap, and then what happens there is a read is like, oh, log of n. It's so cheap that I could hit it so many times that it doesn't cost me anything. The writes are actually done by an actor system, and I don't want to get into all the details, but what you need to know there is, because I've done your classic separated from the reads from the writes in CQRS, I can actually scale this up pretty well and have multiple agents reading from the same source without much contention, and it's all immutable. And that's what it's saying here. Oh yeah, it's saying scaling is O of log of 1, and it's not O of 1, but fine, whatever. It's close. It's pretty damn fast as it is. It says the theory's 10 to 15 million tokens queryable at 64K budgets, but realistically, I had to cut it down to a budget of 4,816 because I've seen that the LLMs or the agents connected to it only pull those three. They never max out, and it's pretty stupid to go over 32K anyway. What I have seen, which is really interesting, is I've seen extreme compression cases where it goes up to 2 or 3 million tokens, and it's still able to come up with something that is relatively readable for an LLM at around 16K, 4,816. But when you get down to 4, it's so compressed that it's probably not worth it. Other things that, and then I'll jump to a question though. There's other concepts here as well. The entire memory system is based on a hybrid where there's stuff that's streaming in, but there is a section that is dedicated to that historical memory. So I can have a context window that's 1 million or 2 million tokens long. Of course, in your traditional coding agent, you probably keep about 40 or 50K tokens. In this case, we always guarantee that it's 16K, but it's 16K compressed and guaranteed that it covers the topics of about 1 million K, even with 1 million tokens, even with compression. Other small things that there's things like contexts. Contexts are basically this idea. It came about because it's a collection of topics that are bundled into one query, so that if I wanted to pull up a specific topic, it would be able to do a complete context dump in one query, just like you see here, but it's on steroids. The other reason why I had context is because I had a situation like this where I was working on one machine. I had a right to several hashtags, but the problem I had was it was hard to keep track of them all because I have 11,000 of them. So I'm only human, so you could imagine how hard that is to keep track of them. But if I actually kept them to a specific topic, and I said pull up this context, I could actually have it follow the machine, follow me on different laptops and desktop machines, and it does that really well. And of course there's other things like temporary topics, temporary contexts, which are automatically deleted after 2 weeks. Other things, but essentially this solves the problem of having the same Groundhog Day conversation twice. I might still have those conversations, but for example, with just pulling up how the bag of holding architecture works, I just drop a hashtag in there and it pulls it up and it gets it right away. There's no more explaining this or trying to have it read a doc. You just tell it, read this hashtag. And that's essentially how the memory side of it works from a consumer perspective. The fun stuff happens when we start talking about context memory. So with that, I think we're at 30 minutes, but I'll take any questions you might have because I don't really have a format. I'm just kind of waffling on based on what I remember and what this thing remembers.
All right, that sounds good. Yeah, we've had quite a few questions coming up. A lot of them are around like the retrieval. So starting with Andrew asking about embeddings and a virtual window.
No embeddings.
What about the virtual window?
What do you mean virtual window?
Like a scrolling 16K token virtual window.
That's the interesting part because open code on disk actually stores the entire uncompressed length of everything. So you actually could say what the virtual window is and it'll scroll up. So it has the original text stored separately on disk. So at one point I set it to around 500 lines or something like that. And you could scroll up and you'd still be able to see it. But that's stored separately from the memory system. That's just your plain old open code vanilla storage. I think there's a setting there. You can just change yourself to make it like 500 lines or 500, however many lines it is, you can scroll up.
So can the agent go from the summary to like the next level in the pyramid to get more information and then more information?
Yes. So that's actually it's you could think of this as different resolutions of an image, but in text, if that makes sense. So I originally started with 10 different sizes. Largest size was 64K, and the small size was like 128 tokens. But in practice, because it actually does eager compression of all the tokens, those three bands where it's 4, 8, and 16 are the ones that are most used. Anything below that, it's like you're basically generating, single line topic titles, which doesn't really add anything. Anything larger than that kind of defeats the purpose, because if I go for 32K tokens, most content, unless you're looking at large chunks of code, is probably around 32K. But the key thing about that is that the source code is never stored in the bag of holding. It's actually information about different facts. And given that I have about 11,000 topics and it grows, and the system can create more topics as temporary topics as a result of investigations, it's pretty much infinite, right? Because you can, if you want to get rid of a topic, you just make a temporary topic and you just let it expire in 2 weeks. If you want to create another one, it's just a different namespace and a different hashtag. So that's why I got up to like 11,000 in 6 months. It used to be 15K, but I think there was a lot of temporary topics that expired over time. But I don't really track the exact number. But let's just say it's around 10K.
So Francis is asking how you find the topics. How does the tool do the searching?
Oh yeah, so this is the cool part. So the MCP server actually has calls into the REST API. The REST API calls into Postgres. Postgres has a 4K snapshot of every single one of the 11,000 topics. So you're basically doing a text search on 11,000 rows on a table. That's tiny. And so that's like a 4K snapshot. So it's like a select.
Yep.
Yep.
Like so it's full text search kind of thing.
Pretty much. Yeah, it's not as exciting as it sounds, but that's basically it, right? This is vanilla tech applied in a way that is really useful, right? Of course, it used to be Redis, but the problem I had with Redis is that Redis text search was really slow. So I figured if I could take the 4K summaries of every single topic and have an event-driven approach, which constantly writes to the table every time it changes and a compression is done, then my job's done. And that's a simple select, right? So there's not, again, there's the side that looks like magic, then there's the real reality of it is this is just a select statement attached to a REST API call.
Very good. All right, I will keep looking through the questions. What have we got? Francis was wondering the 4K summaries. We're talking about 4K tokens, are we, or 4K?
4K tokens.
Yep.
So 4K tokens is I just approximate. So it's not exact, but the rough finger in the air estimate for tokens is 1 token is 4 bytes.
Fair enough. And can you have your agents writing on the same topic? Like if you wanted to do research on one topic. Yep.
Absolutely. They can. This is actually one of the reasons why I built it. So what I've done is I've done 10 investigations at the same time, writing to the same topic with 10 different angles. And the back end is able to take the eventually consistent summary and combine all 10 different perspectives. Now, the part that's actually quite subtle, that isn't really immediate from the discussion, but I have to bring that up, that it is different from all the other compaction approaches that you might get, is because everything is immutable, you actually get timestamps of and the history of all the changes, like it's Git. Now, why is that valuable? The reason why that's so valuable is that when I feed this to an agent, it actually sees the change of updates over time, and it sees the evolution of all the information within a topic. So why is that important? Because if I'm actually doing an investigation and then I find that something's wrong and I keep adding corrections to it, then what's actually interesting here is you could say, well, this changed over time. This is what we found. This is another stuff we found. So it's not overriding anything. It's just pending, but the summary keeps growing. However, on every single topic, there's different resolutions of 4, 8, and 16K tokens, and they're guaranteed to be under those size, fit within those sizes every single time. And that's a huge thing, especially with agents, because you never run into context exhaustion. That's one thing. The other thing that I think the vanilla open code version never solved, and you could look at it in the repo now, is that they never solved the problem of what happens when you run out of context memory, or what happens when you get context that is too large, that it no longer fits in memory. How do you shrink things? They go for compaction, but that's it. Now, one thing I haven't mentioned here that's slightly different is everybody familiar with Claude MD or equivalent or a Copilot? I don't know what the equivalent is.
Yeah.
So one of the things I learned is that you can actually have better context management if you. What I did in this particular build is I actually added the context of marking different sections of your equivalent of Claude MD as either immovable, important, standard, critical, optional, disposable. It's using these handlebars templates, and the idea there is everybody runs into this problem where you've got a big system prompt file and it does not move. But there's certain parts of it that you can either shed temporarily for maybe one turn, and then in the next turn, when there's enough space, it can just expand all over again. So what I've done in this particular one is I actually have different sections of my Claude MD file or the equivalent that mark it as different parts of it as important, like don't delete prod, for example, or I don't know, whatever you want to do. There are other sections that are just basically stuff that are nice to have, and I can mark that as nice to have so that when shit hits the fan and there's not enough space, it'll just shed that part, but all the critical, important parts of the context still stay there. There's also the historical section, which is basically your conversational history, but the interesting part about that is that actually shrinks and expands. So the difference here with how this does context management is that it treats it as almost like a 3-dimensional thing, or even 4 dimensions, because the context window is always evolving, but it's always growing and shrinking and growing. It's almost like it's breathing. And it might shrink temporarily for one turn. It might expand for one turn because you might not actually have enough information in there. But there's certain parts of the map context that you can shed that the agent really doesn't need to have in order to do the job that's right in front of it. The analogy I like to use is when you're driving, when you look at your rear view mirror, you don't actually have to have everything in detail. You just need to know just enough to be able to know where you're going to go next and where you came from. But as you're moving, you're driving your car, you don't actually have to have all that information at once. There's certain parts of it that can be cut away from your view, kind of like viewport rendering. But that's the principle behind this evolving context. Now, when you combine that with a memory system where everything's immutable, you can have sessions that last for days. Not because of any magical trick, it's because the context window grows and expands depending on what you have in it. At the same time, because this memory system stores everything and it makes it cheap to store and read things, then even if it disposes of, say, your past turns, it still has that information saved somewhere. The one thing that's really interesting here is that every single agent session has a hashtag. And it works so well that when I actually have the orchestrator try to recover when a sub-agent crashes, it could read the hashtag. It could read what actually happened in that session. On top of that, the other cool thing I have is what I call two things, actually. There's the scratch pad. Now, the scratch pad is an interesting one because a scratch pad is essentially a section mapped into memory for an LLM or for this agent that is guaranteed to be around 4K tokens anytime, all the time, and the agent can write to it at any time. Think of it as a bag of holding with a pocket dimension that you could write all your notes in, but it's always guaranteed to be 4K tokens. So you could imagine what happens when you've got an agent that goes through its work. It does an investigation. It writes its findings to that scratch pad. It's pinned to its context. So it's almost like a heads-up display for the agent. So that as it's working, you can actually see the scratch pad and say, well, this is what I found so far. This is what I'm working on. This is what I'm doing. So that gives the agent a lot more room to work with. Now, the other part, aside from the scratch pad, is this idea of following specific topics. That one's interesting because I can have it write out a plan that fits within 4, 8, or 16K tokens, configure the harness so that that particular hashtag is pinned to its context. And because it's pinned to its context, it stays there, almost like a sticky note on their screen. And that could be anything like their execution plan, the findings from a previous investigation. It works pretty well in that sense. So again, it's this kind of mapping the context window that gives this kind of flexibility. Now, again, all the stuff that you see here is based on things that 99% of you will already know. It's just, in my case, I just layered it on because I got annoyed. So annoyed that I just built the next thing and the next thing and the next thing, and then it became quite useful. Now, some of the things I've actually built with it, to be fair, to give you an idea of how far I've gotten with it, is this entire open code instance was built using agents that were sharing context using the memory system. I literally had agents, without even reading a single line of open code, all my agents running in a multi-agent pipeline were able to work together, fork it, add roughly 1,900 tests to it. And the difference between this and, say, open code Vanilla is around 50,000 lines of code, 1,900 tests. And they were even able to research the open issues in the public vanilla repo, find fixes for it, and then apply it to the fork. And I've never seen the code. But it did all that because it had all the notes on every single line of code there is. And it was really easy if I wanted to bring up that information to bring up a hashtag and say, read this. So that's the difference. And there's a lot of other useful things for it. Like I did mention in the description for this talk that you could actually make songs with it in Suno. So that's my new hobby. There's an interesting story around that. And the story is that I just was curious because I wanted to see if I could take something that is just completely off the wall, has nothing to do with coding, and actually just apply it to my memory system. And the cool thing there was I think I took my wife's stat deck. It was something that's about how we met, and then fed it through the memory system, and then it had a bunch of skills that translated that into an actual love song, and it came out pretty well. But it's not just about love songs, it's also being able to take things like skills and ideas and do kind of research and just save it there and recall it there anytime, and use it in ways that make it really, really easy to do things that you would never be able to do if you just didn't have the memory for it. Again,
So
I'm not gonna...
How does the linkage between the different topics work?
Right. So okay, well, what I'll do here is I'll show you the tool calls here and I'll explain to you. But how it works is that there is metadata stored about these topics, how they link together. So it's, I think it was in Redis or Postgres. It's in Postgres now. In Postgres, it actually stores how these topics are related together in a graph. There's about 23 different tool calls, not 21. And they do various things. So for example, I could list topics, I could search them, I could get the related, I could get the topic stats here. These are all for the LLM to be able to crawl through my knowledge base and be able to pull different things. Interestingly enough, when I had Opus on this thing, it was doing some really unique things that I never thought it would do when I was having it write songs. Because it was able to pull it past songs that I wrote, in the lyrics that it was producing, it had callbacks to other songs, and it was saying, well, you mentioned this, and then it felt like I could make an entire album where it was talking about different things, and then it would actually talk about like something about 3 songs before. So it felt like this consistent experience because it remembered. The other call out that I probably should mention is that in my system prompt, I actually can do bag of holding hashtags. I can actually have it in the system prompt. It could actually pull up a particular bag of holding topic. And what's really useful there is I've got an actor system in the background that runs once every night and does a summary of all the stuff that I've done. And what I could do is, if you look at this, I could do, tell me what I have done based on, let's say, 14 days. So I'm not going to pull that one up. But anyway, the idea here is that I have an automated process that pulls up all the activity that I've done across the entire memory system every single day. And it writes it to these various different topics. And then I embed that into my system prompt. So all of a sudden, my agent knows exactly what I've been up to for the past 2 weeks, or the past 24 hours, or past week, or 60 days. And that's useful because now I get something that I can never get with Claude or any of the other coding agents, and that's continuity. I could be talking about something, and then out of nowhere, it'll say, "Well, you didn't you do that last week?" And I was like, "Oh yeah," and that's one of the surprises that you get with this kind of system that works because yes, there's no bells and whistles, but what I'm more interested here is having that level of continuity where it feels like it just knows. And if it didn't know, you could see there's all these tools, like for example here, there's these relationship operations where it can relate topics together, it can unrelate them, it can clear a topic graph. I mentioned context, which is basically trying to bundle topics together so that if I told it to query a topic, it basically does a massive context dump of say 10 topics, but even with a context dump of say 10 topics, that's no more than 40k tokens. And that's the best part. It gets it right away. And if I just did the back of the envelope calculations, 10 topics could be up to 10 million tokens squished down to 40k tokens. And that's exactly why I built this.
So is it managing its own like groups and stuff? Is that all automatic by the?
No.
I mean, is that in the back end or is that in the front end agent? If that makes sense.
No, so the front end agent is the one that saves the context, and I just tell it to save it.
Mm-hmm.
So I intentionally made this more of IA, not AI, and that IA being intelligent augmentation. This is built to be an extension of me. There's no smarts here. It's just built to extend my capabilities with working with coding agents. So if it needs to save a context, I say, well, save it into this context. Mm-hmm. Or if I wanted to get up to speed on a topic, I tell it to load the context or read a hashtag. Of course, when in more advanced scenarios, I actually have entire orchestration protocols saved in one hashtag and say follow that. And it'll actually follow it in detail. But that's a different topic. But the idea there is there's all this information that if I wanted it to do something, I could just say read this hashtag, get up to speed with it, and continue with that. Another example that is really useful that happened to me just yesterday is I think one of my machines was not properly configured because I gave up on my GitHub Copilot subscription for different reasons, and then that particular machine wasn't configured on it, so I couldn't use my sub agent, so I had to transfer my work to another machine. So I had one session essentially say I had to do a handover prompt pushed into a hashtag, go to my other machine and say, well, pick up from this other session, here's the repository directory, read the hashtag, and then was able to pick up where it left off. Because everything that it needed to know is already in the other hashtag. And since, for example, I can switch to this one and it'll be able to read it, then that's where it gets really useful because now I when one agent knows something, they all know it. The other useful thing that I found, which seems kind of counterintuitive, is that you don't need a state-of-the-art model if they remember things. Why? Because if you've got 100 agents that make 100 mistakes and they all learn, and when one agent learns from a mistake, all of them learn. So that's why you can see I'm on Minimax M2.7 because yes, they're not as smart as the Claude models, but because I've got a memory system that effectively makes it so that when one learns, they all learn as long as they know what the hashtag is, and I set it up the prompt so that they read it, then effectively I get a system that gets wiser every time one of them makes a mistake. So you could, I don't know, if you want to do the numbers, if 10 of them make one mistake and then all of a sudden it writes it to a lessons learned hashtag and they all read it before they start, then all the remaining 90 agents or however many aren't going to make the same mistake or less likely to. So that's the kind of thing that you can do with a memory system that works. It's not flashy, but you could tell the difference when you don't have to explain anything anymore, or you focus more on the difficult problems that you have, like trying to understand a code base or trying to solve a hairy problem or trying to find a different approach. In my case, this has been running for around 6 months or so, but I easily, once I get to a point, I can scale this up pretty well. The other interesting story that I ran into was when Claude Code Teams came out. I tried it out, and I had Opus compare versus running on this versus running on Claude Code Teams, and it basically said Claude Code Teams got in the way because Claude Code Teams was having agents talk to each other directly, and with this one you don't need to do that, simply because the memory system is the orchestration. The information passed between agent is always guaranteed between 4, 8, and 16K tokens. So even if an agent did about 1 million tokens worth of context in it, you can pass the baton to another agent, have it read the summary of what the previous agent did and review the work, and still keep going without actually having the agents fall over. And it would be seamless because you don't need to worry about context management. It actually just flows quite well. So that's the system in a nutshell. All the other stuff you can see here is useful simply because there's no compaction. I think one thing I need to share is my old dashboard. I'll bring it up, and this is a good way to cap this off. Is I actually let me see if I can bring this up. Probably the most useful thing here is, let me see if I could share the right screen. Now, what I actually did was I actually created my own Claude website. I never actually used it, but as you can see, this is an entire site that is just like a chat website. It helps me, and this is just the dashboard, but the idea here is that the same system that is able to manage context is also the same one that allows me to have conversations as if I never left using or stopped using Claude. But there's a lot of it's kind of hard to compress 6 months worth of all this work into, say, 1 hour, but hopefully that gives you an idea.
Definitely. We got a few more questions as well, Phil.
Sure.
So let's see. So Francis is asking about how the graph is implemented. Using something in Postgres or red-green trees or.
Actually, this is the fun part. So the graph is essentially just a metadata. Like you're basically in Postgres, it's basically it's a table that basically says which topic is related to which topic. It's really that simple.
Like foreign keys, classic stuff.
Yep, classic, like 30, 40-year-old tech.
Yes.
The actual implementation for the compression itself is what I call the secret sauce, but essentially it is a tree. You can think of it as a pyramid, where the layer 0 is all the immutable content that is never deleted. You just append only, and then the actual mutable content that you can delete is the pyramid of summaries that are actually representing however many millions of tokens. And then you've got a read side which is a REST API, and then you've got a write side, which is really interesting because it's actually trying to pre-compute what you would need to shrink. It's a greedy combination of trying to figure out what combination of what level blocks would get you 4K or 4.8 or 16K of compression as things stream in. There are downsides to this. For example, previously this used to be expensive as hell. because I go through around 2 billion tokens a month.
Wow.
But I'm on
How
a
much
I'm on a
cost?
oh yeah, it's like $80 a month because I'm on a Chinese plan that gives me around 15K requests a day. No, 15K requests every 5 hours, or 150K requests per week. So that took my cost from, depending on the usage, it's less than $80 a month. But the nice trade off there is that all my coding agents are plugged into it. There's no compaction. It just keeps going. That's why I can run autonomously. It doesn't pause. It'll just keep going until it stops or it gets to a certain point. But generally, it just goes on forever.
So Francis is wondering what the name of your plan is, the Chinese plan.
It's the Minimax coding plan. It's called Max High Speed.
Max high speed. And Andrew's asking if you had a look at some alternative memory services like Doobie-Doo and Mem0.
Oh yeah, I think I haven't looked at other ones, but I found that I think they were a little too over engineered. Like, and the other reason why I didn't go with other mem services is I needed something deterministic. None of these services are deterministic. Like if I want to get a specific memory, I just want that. I don't want it vomiting a lot of things that are similar, and that doesn't work for me. At the same time, if you change the embedding model, you run into a lot of drift and it gets messy. This entire system is 100% deterministic.
Mm-hmm.
So when I ask for a topic, it's everything about that topic, and topics are cheap, and I could make up to 100,000 of them, and it probably doesn't take any more than a few gigs or so. And that's the whole point. Like I can keep growing this indefinitely, and it's probably still going to fit on a USB stick from 2016.
And Andrew's wondering about, have you tried the Gemma embeddings model from Google?
Nope, I intentionally didn't use any embedding models at all.
I think maybe it just means the Gemma, the lightweight one that Google released open source. I think I think it's a full LLM, isn't it? Or is it just embeddings? I thought it was like a tiny Gemini, basically.
Yeah. No, I haven't.
I think, 300 million parameters.
Yeah, I intentionally avoided any kind of similarity or embedding models. There's no chunking here. This is all custom, but it's built in such a way that, again, when I want something, I always get it 100% of the time. There's no faffing about. I don't have to worry about. I think the only LLM that I actually have to worry about is the one that does the continuous compression. And I think
using min-max for that as well, for the compression, right?
Yeah. It used to be Copilot, but that was kind of expensive because they actually that was expensive. But I used their free models to do their free or 0x models that they had on the Pro plan, so that it didn't cost me anything. But I found that because they started rate limiting everybody, then I just said no, it's not worth it. Minimax, it's the nice thing about using continuous compression is that it doesn't have to be super smart. I was using GPT-5 Nano, and that the cost of that was okay, but it's nowhere near the Chinese models where it's like I could do as many of them as I want to. Future directions I've thought about is I could do multi-dimensional summaries, which is instead of one generic summary, when something comes in, I can have it look from 6 different angles and try to summarize it from however many angles there are. But generally, this system has been rock solid, and rarely given me any problems, and it's battle tested, and I use it every single day for everything. I think the part that I intentionally made it was I made it for me, and I don't think I would have built it this way if I had to build it your typical Scrum and product style, because I would have had to compromise and do all those things. No, this was just to solve the problems that I had, especially doing dev for myself. If I had to productize it, then there would have had to be a lot of compromises in terms of security, and it just would have killed it and given it a crib death. So
is
in this
it
case,
available for people to use if they want to?
no. That's the tricky part. But there is it's good enough that there's two versions of it. There's the version that I have in .NET, and I actually use this stack to rewrite the whole thing in Rust. So it runs on a single, it doesn't even need a container anymore. It just runs on a single binary. Not sure if I'll ever make that public, but if somebody wants to pay me, I'll think about it. But generally speaking, yeah, this is everything that you see here is stuff that you can build. If I were to go run through the list, getting two agents to talk to each other, that's two MCP servers and one REST API. How you store it is an implementation detail. Doing continuous compression and summaries. If you know CQRS and you know how to make sure that reads never block on write, and everybody knows that, then you can do compressions async. If you know actor systems or something similar where you've got an event-driven system that every time you update, you trigger an update and then you run it and then you do the compression and then you make it eventually consistent. That's not 2026 tech, that's 2016 tech. Everybody knows that. Now plugging it into a memory, your favorite coding agent, not hard either, because if you build a console app that connects to the REST API and pulls the data for you, then all of a sudden you don't even need MCP anymore. So again, my point here is that I'm not here just to show off and say, hey, I built this cool thing. It's the fact that everything that I used to build it was based on principles that everybody here already knows from like 10 years ago. It's just never been applied within the AI space because there's a tendency to think that this is a new thing when the problems that you're actually trying to solve are problems with distributed systems, eventual consistency. But we all know this, in .NET. So it's not a new thing. It's just a new thing applied in a different way.
We are coming to the end of time. So does anyone have any last questions for Phil? Chuck it in the chat. Maybe time for another one or two, or can you call it a day if there's no more? Just a sec or two. I must say the questions to ask for the JetBrains license is kind of tricky. Let's see. We've got Francis saying one day LLMs will be deterministic. Maybe. Yeah. No more questions, I think. So, nothing yet. Right. Well, thank you very much, Phil. Don't go yet, and don't think you're done. We'll do our questions for the audience, but that was sure. Quite interesting, I must say. And yeah, right. Like, just as people need to keep track of all these things that they know, the agents need to keep track of these things, and the fact it's got better tooling for its memory management. You're getting to the point where the agent is able to control its own memory, right, to a higher degree, or are you still controlling how it bundles everything together, and that, like, the organization, right? It's got the linkage of the tree. Is that being filled in by you or being filled in by the agent?
By the agent.
So the agent's doing the tree linkage between topics, or just with the pyramid up and down?
No, actually, the pyramid itself is an implementation detail. That's like way lower in the stack. So those summaries are actually done transparently to the agent. The agent doesn't know how those summaries are being done.
But it does combine topics to the tree.
It doesn't. It relates them. So, for example, when you relate two topics, you're making a REST API call, saves it into Postgres. It says these two topics are related. When the agent is effectively a user into the system. So when it actually says, well, give me the related topics or relate these topics, it's just making another REST API call effectively through the MCP or the CLI tool that I've got.
Yeah, you're giving the agents much better tooling for its own management of its own memory. Yes. In a way, right? It's got a much more explicit understanding of what it remembers and how it can save it then.
Yes. Again, it surprises me sometimes because when it's doing things like writing songs and writing stories and things like that, it calls back to previous events and previous stories as if it's one continuous narrative, because it could actually navigate the graph and say, oh, you talked about this last time. So that was really surprising, because usually when I write these songs just for fun, and I get into like real details. Like, for example, I'm a big cyberpunk fan, so I wrote one song, actually an entire album on it, and it was actually talking about songs like 3 tracks ago, and it was very clear, like, oh, you talked about this, and I was surprised because I didn't prompt it. It was just the fact that it was able to go through the graph and notice that I talked about those things, that when it wrote the next set of songs or the next set of content, it knew exactly what I was talking about. Now, in terms of coding, it really helps because within my own system prompts, I actually have what I've been working on the past week. So if it sees anything that I've been working on in the past, it might bring it up and say, well, you worked on that, didn't you? Or and then it would ask me about that, or it would mention it in passing. And even I get surprised because I forget about it, but it knows it, because that's the system. It's automated in that sense. So my take on this one is, a lot of people spend a lot of time building OpenClaw and building the personality. I went the other way and built the memory so that I could swap out the LLM with whatever I want and still have the information to work with. So in that one fine day that I upgrade to Mythos or whatever super LLM there is, it's still going to be working on the same information. When something supersedes that one, or I change it to a different model, it's just the memory. The memory is everything, right? It doesn't matter how smart the LLM is. If it has the memory of a goldfish, doesn't matter. I would rather get something like Sonnet 4.5 level, where it consistently performs, not the best, but the fact that it remembered what I did last week and 6 months ago, that actually helps a lot more. And when I multiply that times 100, and I don't have to pay 100 times more expensive, then that's the part where it really pays off.
Very cool. So I think Andrew's summarized it really well. So he said Phil is always ahead of time with his talks. Anthropic is always hiring Phil. You should go and do a demo for them. And Francis said you should start your own AI company.
I'd love to, though, but I like my day job too much. And at the same time, if Anthropic came to me, the only reason why I would ever join them is so I get access to Mythos, like everybody else. But we'll see.
We better wrap up, and I'll quickly ask a couple of questions, because we're already at 8:15. So for the audience, for a JetBrains license, so please give me two problems of the current way that Claude and other systems do the compaction. When they fill up their context window. Yeah, just pop your answers in the chat. Here we go. All right, Stephen Smith. Yes, we've got forgets and runs out of memory. That sounds pretty good. You're happy with that, Phil?
Yep.
Yeah, and there was other ones. Definitely. Like, I must say the speed is surprisingly slow when I'm using, Opus 4.6 agent. It stops to compact for quite a while. It's time to go and make a cup of tea practice when you get the compaction kicking in. Cool. So, Stephen, send me an email just so I remember to send you the license. And for the next question, I guess what are two benefits of Phil's model over? Well, I suppose that's really the same question. So, what's the sort of model that Phil's been talking about, like the sort of structure? If you were going to draw the way he's got the summaries and things happening from the original all the way up to the smallest one, what sort of shape would that be if you were drawing in a diagram? Does that make sense, Phil?
Yeah. It's not a circle.
All right, Steve, you have both licenses. Do you need two, Stephen? All right, I'll try asking another question since Stephen doesn't need two. So, what was one of the interesting properties on the size of the different summaries that Phil was talking about? Like, if you had a huge amount of data, what was one of the benefits with Phil's model? Memory system more than model red. Andrew's got determinism. I was fishing for something else, but maybe that works as well. You happy with determinism?
Yeah, that's one of them.
All right, that sounds good. Yeah, I was thinking more about the fixed sizes, so that always you had like a certain size that would be able to fit in the context. But my question was a bit off the cuff because we ran out of questions.
Open-ended, yeah.
Yes, so let's go with that. So Andrew, send me an email as well, and I'll send you another license kit. Yeah, so thank you very much, Phil, for sharing and for your stand up with alt.net, your regular stand up with alt.net on the latest and greatest in like extending what people are doing in models and memory. It's usually memory, right? In fact.
Yeah, it's all about memory. I think to be fair, memory. If you have not built your own memory system, it's like the ORM of 2026. So if you have not built one, you need to build one.
That's right. No more object relational mapping. We've moved on to grander things.
Yes.
So you got thanks in the chat there, and yes, certainly from me and Francis as well. So if you want to stick around, Phil will be stick around afterwards. And thank you, everyone. So next month we've got Obsidian. So yeah, stay tuned. We'll send you details as usual. All right, catch you all later. Bye.